Hello, I'm Kylee Furniss, and in this video I'm going to use my mediocre artwork from MS Paint to explain conductors and insulators and how charging works with each of them. Let's quickly review some foundational concepts of charge. There are two types of charge, positive and negative. Negative charge is carried by electrons. Like charges will repel one another, while opposite charges will attract one another. In any interaction, charge is conserved. If an electron is removed from an object, it will be transferred to another. Charge doesn't just come into and out of existence. Insulators and conductors are two common types of materials. We are going to discuss their features and how each of them is charged. Let's start with what they have in common. Both conductors and insulators are composed of large numbers of atoms or molecules made up of atoms. These atoms and molecules have positively charged nuclei surrounded by negatively charged electrons. The nuclei are fixed, meaning that they are not transferred from one substance to another. In solids, the nuclei also does not travel throughout the substance. The most significant difference between the two is that in insulators, electrons are also fixed around their atoms or molecules. In conductors, however, electrons can move freely throughout the substance and are not bound to individual atoms or molecules. This difference leads insulators and conductors to have very different electrostatic interactions, which is going to be pretty important. First, we're going to look at insulated materials. Examples of insulators include rubber, glass, oil, diamond, and dry wood. Let's look at insulated material on a two-dimensional plane. This insulator would actually be made up of molecular compounds of atoms. However, for the sake of simplicity, we're going to look at it as if each molecule is one atom with one fixed nucleus, one valence electron, and a neutral charge. The positive and negative charges here cancel out, giving the insulator an overall neutral charge. First, we're going to discuss charging by friction. Rubbing objects together can cause electrons to move from one object to the other. When the rod is rubbed against this insulator, we can see that an electron was removed. This leaves the positively charged nucleus without a valence electron to balance it out. Obviously, more than one electron would be removed from the insulator, leaving many positively charged molecules throughout the insulator and giving the insulator an overall net charge. Friction can also lead to electrons being added to the object. When this rod is rubbed against the insulator, electrons transfer from the rod onto the insulator. These added electrons stay right where they are initially, since electrons can't move freely in an insulator. The insulator has a net negative charge because of these excess electrons. An easy way to see an example of this charging by friction is that when we rub a rod against a piece of fur, electrons will transfer from the fur to the rod. It'll leave the rod negatively charged and the fur positively charged. Another way we can charge insulators somewhat is through polarization. So neutral objects are attracted to charged objects, whether the charge is positive or negative. When the charged object is brought near a neutral insulator, it polarizes its molecules, with the electrons fixed towards the positively charged object, like in this example. The same shift would occur if a negatively charged object was brought near the insulator. But in this case, the electrons are actually moving away from the object as these negative charges will repel each other. The whole object is now shifted, with one side more negative and the other side more positive. The polarized object will be attracted to the charged object. Let's look at a couple examples of the way that we use insulators. We use rubber, plastic, and even sometimes glass to surround a conductive wire This prevents the charge from moving off of the wire. Those working with charged materials also wear rubber-soled shoes, which are insulators, and which prevents them from being shocked. As I was growing up, my dad would do the electric work on the house, and every time I helped hand him tools when he did this, he made sure to point out to me that his shoes were rubber-soled to protect him. Next, we're going to look at conductors. Inductors include mostly metal materials, for example, silver, gold, copper, and steel, but may also include liquids with charged molecules in them, like seawater, which is full of salt. To understand conductors, we need to understand metallic bonding. Conductors, like insulators, are materials made up of atoms and molecules with fixed nuclei and valence electrons. In my animations, each circle with a plus sign represents an atom, not including the valence electrons. These atoms have a positive charge. They each include the positively charged nucleus and the non-valence electrons around them. The valence electrons are not lost, but surround all of the positively charged atoms, balancing them out, the way electrons in neutral insulator balance out the positive charges. In conductors, however, the valence electrons are not localized around their individual atoms. Instead, in metals, these valence electrons detach themselves from the rest of the atom and move freely throughout the conductor. These free-moving electrons create a sea of electrons surrounding the fixed atoms. At this point, the charges all balance out and create a net neutral charge, and the electrons are evenly distributed through the conductor, so there is no polarization. First, we'll look at charging by contact. Where insulators require friction to transfer electrons, conductors can transfer electrons just by contact with a charged object. In this case, we brought a negatively charged object and touched it against our conductive material, allowing electrons to transfer into the conductor. These added electrons give the conductor a net negative charge. They don't have to stay in the same place they were added like with insulators. They can travel throughout it and generally are going to create a net charge throughout it instead of like a polarization effect. The opposite effect occurs when a positively charged rod makes contact with a neutral conductor. Electrons flow out of the conductor into the rod, leaving a more positive charges than negative. This leaves the conductor with a net positive charge. Next, we'll look at charging by induction. It involves using two different conductors. When the conductors are in contact, electrons can move freely between them. They become kind of one conducting unit. When a charged rod is brought near the conductors, opposite charges are attracted to the rod, moving towards it. Like charges move away from the rod into the other conductor. While keeping the rod near, the conductors can be pulled apart so that charges can no longer move between them. This leaves one conductor with a positive charge and the other with a negative charge. Now, when the rod is pulled away, the charges move towards one another as like charges attract. Thus, the two conductors that were initially neutral are now each charged. Here are a couple examples of how we use conductors. We use conductive materials, often copper, in wiring to carry an electric charge across a distance. Iron is also used in engine designs to conduct heat. So just to summarize what we learned, we talked about conductors versus insulators and learned how they work. We talked about how to charge insulators using friction or polarization. We also talked about how metallic bonding works in our metal conductors and how to charge conductors by contact and induction. Here are the sources that I used for both content and images. Thank you for watching.